Hello everyone, today we'll have a quick look at cladding fabrication automation using CladCut. The project at hand today is MISK School Admin Building located in Riyadh, Saudi Arabia. As we can see here, the crown is made out of solid sheet cladding. Our software today needs a DXF file with the panel's outline made polylines. So we just need to extract the DXF file from the model using any software that can export DXF files. 2D DXF files to be exact. The software I'm using today is Inventor. So we'll just start a sketch on this plane, project this geometry on this sketch and finish. Then export the sketch to DXF. Let's save it to the downloads folder. Let's name it admin test. So the only requirement for CladCut is for the panels to be in polyline, 2D polyline to be exact. So it looks to be correct here. I don't need these parts for my project. So we will just delete them. All right, save. Okay. So we will start to make the fabrication drawings using CladCut made by DomArt. So we go to this link, insert your username and password and press start. Then choose simplified method. In this page, we start by inputting the project name and the project number, the client. And the next part here, we choose the material. Let's choose solid aluminum sheet. Now choose the color. Let's say gold. Now choose the material thickness. Let's say 4. Project drawn by, let's leave it as it is. Then press next. In this part, we have parameters for the brackets or the L-angle fixation. The L-angle fixation fixed by your pop rivet to the panel. So minimum support edge distance, let's say 145. The maximum spacing between L angles is, let's say, it's 400. Let's keep it at inside L angle as it is. This is the dimensions for the L angle. This looks good. Then we choose stiffeners. We have two options to add tube stiffener or no stiffeners. Other shapes of stiffeners are coming soon to the software. Then we choose the parameters for the stiffeners. The maximum support edge distance, let's keep it at 200. And this one is 500, which is the maximum spacing between the stiffeners. Then here we choose the bend sizes or the fold sizes or flange sizes. Let's say 30, then press next. And this part we choose the gap sizes if we didn't include the gaps in our setting out in the DXF file, but in my DXF file I included it, so let's put 0 in here. Then we choose the numbering method. I'll choose auto numbering as the software can auto number the panels for me. Let's say part number dash, okay, and the starting number will be 1. Then here we'll choose the standard sheet size for our project. Why this is important? This is important for after the unfolding of the panel, the sheet exceeds the standard sheet size, the software will give you an error. It will still do the panel, but it will give you an error letting you know that this panel is exceeding the standard sheet size that you input. Then here we import our DXF file. Let's choose a file, those admin test 1. Upload the logo. If you have a logo for the company, you can upload it here, then press next. It will take a little bit of time to load the file. As you can see here, the software read the panels and detected the quantity of each panel. Then we can start by pressing start job. In this part, we'll wait for a few minutes for it to generate the fabrication drawings. I made already the same file earlier today, so I'll save some time for you. Okay, the output files for from the software are as follows. We have a PDF file. Okay, as you can see here, it added all the brackets or the section indications, the arrow for the colors, and even did the unfolding views for the panels. The next file we have are an AutoCAD file. So if you need to add or delete anything or edit some small things, but as you can see, it is fairly clean, and the title block has the dimensions of the panel, the area, and the project information. And the last file that we export is a CNC file for the machines. As you can see here, the CNC file has only the unfolded view of the panel, and with this layer named cutting out, and the inner layer is named grooving, so the CNC machine can read it as easily as possible. And that's it. Thank you.
Try CladCut now and lead the way in innovation for cladding facade fabrication. Contact us to learn more.